Now let's do C as fast as we can. It says h of t is equal to the root of 3t. Now we want to be able to differentiate, okay, using the definition. So we know that for us to use the definition, we have to first find h of t plus h, okay? What is that going to be? This is just going to be, instead of t, we are putting t plus h. So it'll be the 3t plus, 3, instead of t, you put in brackets, it's 3 outside. Instead of t, you put t plus h, okay? Because this 3 was affecting t, now it should affect t plus h, both of them, okay? So it's the square root of t plus h. Wherever there's a t, we put t plus h, okay? Which we could then just say the square root of 3t plus 3h. This is what happens. So now we can go on and we can now say that h prime of t is going to be the limit, don't forget limit, I always do that, of h as h goes to 0 of h of t plus h minus h of t, all divided by h, okay, which is going to be equal to, we say the limit as h goes to 0 of what is h of t plus h is the square root of 3t plus 3h minus what is h of t is the square root of 3t, and it's all over h. Now we have to go ahead and get this, okay? So what is this going to be now? Now what it is that, and then don't try to put this 3t into this bracket. You're not allowed. You don't do that, okay? It's impossible. You never do that. So what we can do to get rid of this, when we do, we've done limits where we had a square root sign. What did we do? We multiplied by conjugate to get rid of it. So it's going to be still the limit as h goes to 0 of, now we can multiply that by the conjugate outside. It's still fine. So we'd be saying the limit as h goes to 0. We can still put it outside. It'll be like this, of 3t plus 3h minus the square root of 3t all over h. Then we multiply by this thing, but we change the sign here, is the square root of 3t plus 3h plus the square root of 3t all over the square root of 3t plus 3h plus the square root of 3t. Remember, you multiply the top and the bottom by the same thing. We can just say the limit of that. The truth is, we first multiplied it outside the limit, but the limit laws say you then put it inside the limit. So if you want, you could have said is the limit of this times this, which then just becomes the limit of as h goes to 0 of, now this thing goes inside. So I'm just going to copy so I don't waste time. Okay, say copy, then I will put it here, paste. So it's going to be equal to the limit as h goes to 0 here, but the bracket now goes outside, okay? You now get the limit after multiplying, so it's like this. Then now what are we going to get? Well, it's going to be the limit as h goes to 0. This is the easiest thing when you multiply two conjugates, because we know what you do. What do? You square the first thing in either one. We don't care. You can use this or you can use this, okay? You square the first thing, which when you square this, the square root goes. It's just going to be 3t plus 3h. Then you put minus, then you square the last term. So you square it, it just becomes 3t because the square root goes. Then it's all over. This now comes, this one. It's going to be h multiplying root of 3t plus 3h. Root of 3t plus 3h square root. Then we say plus root of 3t. Like this. So now what are we going to end up having? This is going to be equal to the limit as h goes to 0 of, now 3t and minus 3t will cancel. You remain with 3h all over h multiplying the square root of 3t plus 3h, then plus the square root of 3t. Don't rush to expand in the denominator to try and put h. No. Remember, we've talked about it many times. Denominators, you don't rush to simplify them. You simplify them at the end if they are supposed to be simplified. So that is why I kept the h. Now look at how important that is now. The h will cancel in itself, will cancel this one, it's 1. That is why you shouldn't have canceled. So it's going to be the limit as h goes to 0 now of 3 all over. Why have you been doing all this? Because we can't substitute the limit in here. You can't put 0 in the denominator. That can't happen. So now we'll end up having what? So now this is going to be simple because in the denominator we'll now be having 3t plus 3h, and we now have the root of 3t, And now we can simplify. You see, we have eliminated the problem. The problem was an h in the denominator because we could not substitute 0. For here we can because it doesn't make the denominator 0. So it is going to be, now you can substitute 3 over, wherever there is h, you are putting 0 because h is going towards 0. So now it becomes the square root of 3t plus 3 by 0, which is just 0, right? Plus the square root of 3t. Please put this stage so that they can see that you have substituted. It's important, okay? Then now you're going to get it as 3 over the square root of, if you want to have this next stage even to say 3t plus 0, so that we see you know that the 3 by 0 is 0, then this now just becomes the square root of 3 over the root of 3t plus the root of 3t. So we have a root of 3t and another root of 3t. So we have two of them. So it's going to be 3 over 2 root of 3t. Okay? Then this is going to be your final solution. And we have, but we are not yet done. This is going to be our h prime of t. So we can now say h prime of t is going to be h prime of t is going to be equal to 3 over 2 root of 3t. Now we can start to put the missing values. Let's start to put the things that are missing. H prime of 1. What is it? Wherever there is t, we are now putting 1 in h prime of t. So it's going to be 3 over 2 root of 3 by 1, which is going to be 3 over 2 root 3. Okay? Then we can have h prime of 2/3. This is going to be 3 over 2 root of 3 by 2/3. And this just becomes 3 over 2 root of 3 into 3, 1 into this 1. So it just multiplies to be a root of 2. This is going to be 3 over 2 root 2. I mean, we can leave this as our final solution. This is okay. 3 over 2 root of 2. Okay? Then what would we now have as the other thing? The h prime of positive 3. This is just going to be 3 over. Remember, we are putting where there is a t here. So it's 2 root of 3 by 3, okay, which is just going to be 3 over 2 root of 3 by 3 is 9, and root of 9 is a 3, so 3 over 2 by 3, which is going to be 3 over 6, which is going to be 1 over 2, or half. And this is going to be the final solution, and we'll be done with number 1c. Okay, this is c3. Okay, this is c3, and we can say c, okay, no, we can say this is c3, then this is c4, then we can have this as c2, and then c1 is to get this h prime of t. So these are all the solutions, and we'll be done. We can go to part D in the next video. Goodbye for now.